So let us please start on this side of your cheat sheet. Okay, we are going to run through some things that should look familiar to you. Okay, because you should have like a billion pages of notes. Okay, but you don't get to use your notes. You just get this one sheet. Okay, so if you have a limit where your x is going to a number. Okay, so I'm going to add to this x to a number. There are 4 strategies, okay, that we talked about to evaluate when your x is approaching a number. Okay, the first one is that you should just try to plug it in. Okay, so our number 1 strategy is going to be substitution. Okay, if substitution does not work, do you remember what else we tried? Okay, good. Factor cancel. Okay, then in our notes, we also talked about simplifying. And then in case you don't remember what that means, I'm going to put conjugate behind it, etc. Okay, and then number 4, yes?
So substitution. Right, what would it look like if it doesn't work?
We'll actually go over that. But it's down here at the bottom of your sheet. We'll do it in just a second. Okay, the final one are your 2 special limits. Okay, and we actually only got to one of these. We'll come back and do the second one later. But if you have sine AX over BX, do you remember what we did with that? A over B, very good. You're just gonna divide these numbers, that's gonna be your answer. Okay, this one we have not covered yet. So it's on your sheet because the idea behind having you make these sheets is that then when the AP test is around the corner and you're trying to study for it, you don't have to look through 8 million pages of notes. You'll have like 1 page for each, like sort of like big unit. You know what I mean? So we'll come back and fill that one in later. Okay, now let's talk about if factor cancel worked, that means that there was a hole in the graph and your limit still exists. Okay, if you think about it, okay, if you're able to fix the limit, okay, that means that there's a hole in that spot and your limit still exists. Okay, however, if you have a factor that does not cross out, do you remember what happens in the graph there? Huh? Very good. There's a vertical asymptote there. Okay, so if it does not cross out, you have a vertical asymptote. And remember that vertical asymptotes aren't fixable, so that would indicate that your limit does not exist. Okay, now let's talk about how do you know when you need to factor cancel or apply one of the other strategies. If you get 0 on top and a number on bottom, that is okay. 0 divided by anything is 0. Okay, but if you get a number divided by 0, that's going to be no, you can't have that, DNE. The last option is what if you get a 0 on top and on bottom? Okay, for my kids, we would say you have to do more. Okay, and that's the one where you would want to try to fix it. So you can use factor cancel, conjugates. We'll look at several examples of that together just to kind of get you back to thinking about all this stuff. Okay? Any questions on that? All right, let's run down the right side and then we're going to do some examples off your review. So if your limit is going to a number, that is what you do. What about if your limit is going to infinity or negative infinity? You're going to use Bobo, Botan, Betsy. Okay, Bobo stands for bigger on bottom. And if it's bigger on bottom, that means that the ends go to 0. Okay, that's an arrow. It looks like that's an arrow. Okay, Botan stands for bigger on top. And that means that you have no horizontal asymptote. which means that either your end is pointed up or down, but it's not approaching a specific value like 0 or something else. The last option, Betsy, is if they're both equal powers. And if they're both equal powers, you're gonna divide the coefficients to see what the ends would curve off to. Okay. Then in the notes for this day, we talked about other types of functions. The smallest was sine and cosine or any other constant. The next category was logs and natural logs. Then polynomials or powers. And then, dang it, I ran out of room, but the last category is exponential. Okay, that last one is exponential. Okay, now, remember that the difference between a power and an exponential is that if it's a power, it should be like x squared versus an exponential would be like 2 to the x. So if you want to write that down so that you remember, okay, a polynomial or a power would be like x squared versus an exponential would be like 2 to the x. Okay, so that's the difference between those two. And then remember, this is the smallest working your way to the largest. Okay, next little bit on this. It doesn't matter if you're doing x to infinity or negative infinity, because usually those are going to come out the same. The only time those won't come out the same is if you have one of 3 types of, I call them weirdo functions. Okay, the first one is absolute value. Then any kind of square root or radical. Okay, and if you don't know what a radical means, that just means like any other type of root. So like a cubic root or a 4th root. So I think all of our examples are square roots, but any other type of root, you'd have to do the same thing. And then the third one was exponentials. Okay. If these 3 types of functions are not in your equation, then it doesn't matter if you're checking negative infinity versus positive infinity, because the ends will do the same thing. Okay, now just to make sure that you remember, x to infinity is going to be the right end behavior. And then negative infinity describes the left end behavior. Okay, one more thing I'm going to give you on your cheat sheet about exponentials. Okay, Mr. Castrejón explains this a little bit differently, but for my kids, we talked about that whenever you have a limit as x goes to a negative infinity on b to the x, do you remember that when we plugged that in, we turned that into 1 over b to the x? Okay. And we'll look at examples of that in a second, and I'll try to, I asked Mr. Castrejón how he explained it to y'all, and I'll try to explain it the same way so that y'all aren't confused. Okay, but for my kids, x to negative infinity on an exponential is going to make it 1 over whatever that exponential is. Okay? All right, now that the front of your cheat sheet has lots of information on it, okay, we're going to do this section of the review that has all the limits. Okay, this is the long, I know the review looks really long, but I had people finish it in first period, so it'll be okay. Okay, let's do some examples together to get you thinking about it, and then I'm going to give you some time to work. Okay, so if you will turn to the page that starts with number 6, this is where you have like a bazillion limits. We're going to do several of them together. Okay, first row, let's just start off with, let's actually do number 7, okay? Number 7, what is your x going to? What is it, a number or an infinity? Okay, what number is it? 1/2. Now, if I were to have you plug it in, I'm gonna save you a little bit of time. You're gonna get 0/0. So I want you to go ahead and write that down so that you remember if you decide to study, okay, that 0/0 means I need to do what? Do more. Okay. Now, a lot of my other class forgot how to factor this, so that's why I picked number 7. Okay, the top of that, if substitution doesn't work, means I need to factor. How could I factor the top of this? Do you remember? Okay, we're gonna split it into parentheses. Let me give you choices. Is it a trinomial where it's A, B, C? Is it a greatest common factor, or are they both perfect squares? They're both perfect squares. Let's review how to do that. You're gonna square root the 4x squared. What does that give me? 2x, right? So I'm gonna do a 2x and a 2x, because remember, we're breaking it down into factors. Okay, then what is this? Square root of 1. Still 1, but do you remember it's plus or minus 1? So I'm gonna put a +1 in the first one, -1 in the second one. Now, on the bottom, what type of factoring could I do there? Could I do trinomial, which is ABC? Could I do GCF, or are they both perfect squares? GCF, what can I take out? A 4x, very good. Take your 4x out to the front. What will be left over from 8x squared? If I divide it by 4x, now it's a 2x, and then my minus 4x when I divide it by 4x is now a -1. Okay, take a look at your limit. Remember, I want to factor and then cancel. What will cancel? 2x minus 1s. Okay, and now let me just draw you to this part down here. If it cancels out, what does that mean the graph had? A hole. You did this in pre-calc for like a month, right? And then that means the limit still exists. So once I cancel that out, I want to take that number, go back and plug it in. So let's do it. Okay, my limit was as x approaches 1/2. So now that I've fixed it, I'm going to plug the 1/2 in. 1/2 times 2 is going to give me what? Okay, so that's going to be a 1 + 1 on top. And then what about 1/2 times the 4 down here? 1/2 of 4 is 2. Then I have 1 + 1 is 2, divided by 2 gives me 1 for my final answer. Okay? Now notice that this is the same equation, but now what's my limit going to? Infinity. Now look back at your sheet. If your x is going to infinity, you're doing Bobo, Bot, and Betsy. So look at your question. I have a 4x squared on top and an 8x squared on bottom. Is that a Bobo, a Botan, or a Betsy? Betsy. What do I do with the numbers in the front? Divide them, which means I'm doing 4 divided by 8, which is going to be 1/2. Okay, now in the next example, right next to it, instead of going into infinity, I'm going to negative infinity. Okay, do I have one of the 3 weirdos that could make this come out different? Okay, no, I'm looking for a square root, absolute value, or an exponential. None of those are present, then these are going to match. So this is also a 1/2. Okay, if it doesn't have a weirdo in it, then these should be the same. Questions on that? Okay, let's do maybe one more from this page. Go down for me, please, to 11A. Okay, number 11. First thing I would do is plug in 5. On the top, what's 5 minus 5? What about 5 minus 5 on bottom? And if I get 0/0, what are we going to do? Okay, do more. Then you'll look at your sheet. Remember, if substitution doesn't work, I'm going to try factor cancel. Now, I think on this class, I might have not done this example on the notes. But can I cross these out? No, because the order of subtraction is not the same. So a trick to fix that is on the bottom, we're just going to GCF a negative out to the front. So let me show you what I mean. Keep the top the same. So still x minus 5. But then on the bottom, if I want to flip flop the order of subtraction, I'm just gonna pull a -1 out to the front. And now watch what's gonna happen. If I take the negative out, is my x still gonna be negative? No, now my x is regular and my 5 is gonna be the one that's negative. So that now they can cross out. Okay, so if the only problem with you trying to cross things out is the order and subtraction, pull a negative out and it'll switch the subtraction order. Okay, then from there, what can we do? Cancel these guys out. And then I want to apply my limit as x approaches 5. Okay, but then I notice that I don't have anything left on top. That's a problem. If you cross everything out on top, what do you leave as a placeholder? 1, very good. Okay, and then if I had an x, I would plug in 5, but I only have numbers left, then just divide them. What is 1 divided by -1? That's your answer, -1. Okay, but if there is a number, plug in whatever x is approaching. Okay, take a look at letter B. X is to infinity. Is it a Bobo, a Button, or Betsy? Okay, Betsy is correct. Which means that I'm gonna do x divided by -x. What are we gonna get? Is 1 correct? -1. Okay. Last column, is there a reason that this one will come out different? Okay, I don't have any of the weirdos in it, so that means it's gonna also be -1. Okay, go ahead and turn the page. Let's do 16. Okay, for number 16, what is x approaching? A number or an infinity? Okay, plug it in. This one will not come out to 0/0, so you're gonna get your answer. Okay, number 16. What is x approaching? 4. 4. So now I'm gonna have 4 squared minus 2 over the ln of 4. Now remember, ln of 4 is a number. You don't have to know what it is. You just have to know it's already a number, okay? So I'm gonna leave my ln of 4 the same, but then what's 4 squared on top? 16 take away 2 is 14. That's your answer. Okay, so unless you get 0/0, you're not doing any of the strategies that we talked about. You're just substituting. Okay, now look at letter B. X is going to what? Infinity. These are your Boba, Bot, and Betsy rules. Okay, and then on my sheet, we listed out the order of the different categories. So if the top is an x squared, what category does that fit in? That's a power or a polynomial. And then what about ln x? That would fit into the log. Which one's bigger? The top. And if that makes it a bottom, remember that the N stands for no asymptote, which means that it's a DME. Do you have any of your weirdos in that one? No, so that would also be a DME. Okay, remember, log isn't one of your weirdos. They're on your sheet, but it's absolute value, square root, and exponentials. Okay, one more from this page. We're gonna do number 17. Okay, what is x approaching? 0, plug it in. Two times 0 squared minus 4 over e to the 0. What is 2 times 0 times 0? 0 take away 4 is -4. Is e to the 0, 0? What's anything to the 0? 1. Okay, -4 divided by 1 is -4. Okay, next row, I'm doing x to the infinity. Let's categorize the biggest thing on top. X squared counts as a power. What about e to the x? That would be an exponential. And remember, exponential is your biggest category. So the exponential wins. That means that is this a Bobo, a Botton, or Betsy? Bobo. Bobo, there we go. Which means it goes to 0. Do I have any of my three weirdo functions that's gonna make this one come out different? Yes, remember exponential is one of your weirdos, right? So I'm gonna have the top stays the same. 2x squared minus 4. But then on the bottom, when you negative infinity on an e to the x, it becomes 1 over e to the x. Okay, and now this is not an exponential anymore. Now who's gonna win? A nothing on the bottom or an x squared on top?
X squared.
Which means it's a
Bottom.
bottom. Okay, which means it's a DNE for the limit. Okay, and then Mr. Castrejón had said that for e to the x, just think about the graph. If you go to negative infinity, it's approaching 0, which means that it won't win on that side. Okay. All right. Do you feel like you could do those 2 pages? Some of it?
Yeah.
Okay. I have the key. Ask me if you need help. Okay, I'm gonna give you about 15 minutes to work, and then we'll do a few more examples together.
Are we going to do the back?
We are. We'll do it in a little bit. Yes. Just for the E. So what he had said is that he just had to think about the E to the X graph goes like. So it gets really big, but if you go to the infinity side, which is basically, I would like to think about an exponential. That's how, you remember from like alpha years, that you had like X, like, that you make it 1 over X squared. So that's why we're dropping it to a fraction and once it's a fraction, it's not classified as All right. Okay, go ahead and turn to the page that starts with question 19. Okay, question 19, please. Okay, we're not going to specifically do 19, but that page, you're going to have a lot of weirdos on this page. So we're going to try to hit a couple of each type to make sure that you know how to do it. So we're going to start off with number 20. Which weirdo is in number 20? Okay, 20 has a square root. We're going to infinity. So the first thing that I'm going to do is simplify the top to see what that power is the same as. If it's the square root of 25x4, what is that basically the same as? 5x squared. So I have a 5x squared on top versus 3x squared on bottom. Is that what I picked? No, remember, you want the biggest thing off the bottom. So what am I going to pick? The 7x3 or cubed. Okay, and then I would look at that and I would say, is this a bobo, a bottom, or a Betsy? Okay, it is a bobo, which means it's going to come out to 0. Very good, but make sure that on that one, it doesn't matter that the top and the bottom both have squares. If the bottom also has a cubed, you're picking the biggest thing off the bottom. Okay, now when I go to negative infinity, okay, 4 square roots, you probably forgot this because we haven't talked about it in a while. But the only way these can come out different is like if that one's 5, this one could be like -5. So let me ask you, if this side is 0, could the other side come out to be -0? That's not really a thing. So a bobo is a bobo. Okay, so these are both going to be 0. Okay, but now let's go down to the next row. Okay, we are going to square root 9x to the 6. Okay, 9x to the 6. What is the square root of that? 3x cubed, very good. And on the bottom, what's my power? Very good, negative 6x cubed. Which means that this is a Bobo, a Botan, or a Betsy? It's a Betsy, which means I'm gonna divide the numbers in the front. Specifically, I'm dividing 3 and negative 6. Okay, what's that gonna give me? Negative a half, yeah? Okay, now, could negative a half turn positive? Yes, then we need to check. Versus if it's 0, that's why we didn't check, is you can't have like a positive and a negative 0. All right, so let's do the same thing again. If I square root x to this 9x to the 6, what is it gonna go to? But now we're gonna check the sign. Your x is going to a minus infinity. If I take a minus infinity and I raise it to the 6th power, oops, I wrote the wrong number there. Okay, if I take a negative infinity and I raise it to the 6th power, will it stay negative? They cancel out in pairs. So 6 is even. Don't know. Okay, ladies, let's refocus, please. Okay, so negative infinity to an even power is going to turn to a positive 3. On the bottom, I'm going to take my negative infinity and I'm going to cube it. Is it going to stay negative at first? Yes, because remember, if I do negative times a negative times a negative, only 2 of them can cross out. I'm still going to have 1 left over. But then what am I going to times it by? A negative 6. How's the bottom going to come out? A positive 6x3. And when I divide positive 3 and positive 6, what am I going to get? 1/2. Okay, so remember that they might come out to be the same number, but one of them's positive, the other one's negative for square root and for absolute values. Okay, let's do an example with an absolute value. Let's do number 24. Okay, number 24, is it a Bobo, a Botan, or a Betsy? Okay, it is a Betsy. Divide the numbers in the front. What's 10 divided by 12? Okay, it's going to start off as 10 over 12 and then reduce to 5 over 6 is correct. Very good. Okay, but then to negative infinity, remember, they can come out different because it's got one of your weirdos in it. So when I take a negative infinity and I put it in absolute value bars, will it get to keep its negative? No, so my 10 on top is going to stay positive. Okay, but then when I take my negative on the bottom and I plug it into a squared, will it get to keep its negative? No, remember, even powers are always going to come out positive. So if I do a negative infinity into a squared, my 12 also comes out positive. And when I divide 10 and 12, I'm still going to get 5 over 6. So remember, sometimes they come out different, but sometimes they come out the same. Okay, will you try for me, please, number 23? I'm just going to give you like 30 seconds to look at it. Bobo, Bot, and Betsy it, and then think about the negative infinity side. Okay, so 23, right above that. Okay, is 23 a Bobo, a Bot, or Betsy? Okay, so I'm going to do 6 divided by 3 or by 9, and I'm going to get 2/3, yeah? Okay, now on the other side to negative infinity, what's going to happen to my negative from my infinity if I put it in absolute value bars? It's going to turn to a positive 6x3. Okay, now let's talk about the bottom. I'm going to take my negative infinity and I'm going to cube it. Is it going to stay negative or turn positive? It's going to stay negative. And that means that then my 6 or my 9 is going to end up being negative as well. So now I have a 6 divided with a negative 9 gives me negative 2/3. Okay. Questions on that? No. All right. Let's do one with an exponential. Let's do the one between those, number 22. Okay, number 22, as x is going to infinity, is it a bobo, a button, or a Betsy? Okay, it is a bobo. The top is a 3x squared. And the bottom, the biggest power is 5 to the x. Okay, you should not be using the x cubed because if this is bigger, you pick the biggest thing off the bottom. So if you look at your little cheat sheet, remember that exponentials are the biggest category. So 5 to the x is an exponential. Okay, x squared is a power. So if it's a bobo, it goes to 0, we said, right? Okay, now let's check negative infinity. Okay, if I do negative infinity and I have an exponential, what happens to the 5 to the x? It becomes 1 over 5 to the x, right? So on top now, I still have a 3x squared. Okay, we're going to ignore the 6x because it's not the biggest thing. We want the biggest thing off the top. Okay, but then on the bottom, I had a 6x3 minus a 1 over 5x. And remember that as soon as we turn our 5 to the x into a 1 over, this isn't exponential anymore and it doesn't win. What is the biggest thing off the bottom? 6x. Okay, very good. So now it's a 3x squared versus a 6x cubed. How's it going to come out? Bobo, Button, or Betsy? Still Bobo. Okay, but if they were both x3s, it could be a Betsy, right? Okay, do you kind of get it a little bit? Okay.
But if the first one is a 0, then would that always essentially be
no, and that's because exponentials are like more weird. Let's actually do number 19 for me. And then I'll show you an example. This example that doesn't happen. So try number 19 for me. Now you'll notice that on 19, do you notice that your E already has a negative in it? So you need to fraction that right away, right? So this is 1 over E to the X, just to be lazy. Go ahead, you're fine. So what's the biggest thing on top? Okay, what's the biggest thing on bottom? So is it a bobo, a button, or a Betsy? Betsy, it's gonna divide to what? 5 halves or 5 over 2, very good. Okay, but now look at letter B. If I take a negative infinity and I plug it into a negative on the exponential, is this still gonna go fraction on you? Okay, no. So in this case, you'd have this plugs in here and cancels out the negative. So now that's just a regular E to the X. Now is it a bobo, a button, or a Betsy? Now it's a button, which means it's gonna be DN. Okay? Because your biggest thing on top now is an E to the X, your biggest thing on bottom is an X squared. Okay, now one other thing. If you read the instructions here, okay, just on this page, it says that if it's a limit, if your limit doesn't exist, to put whether it approaches positive or negative infinity. Okay, that is not on your test, but we had it in your notes, so I just want to remind you of it because it can be on the AP test. Let's say I put DNE here, yeah? That means that my limit's not approaching a certain number. It's either going up or down. So to find out which one it is, you're just going to plug your negative infinity in and see how it comes out. So on the top, my biggest power is E to the X. Okay, E to the X on its own is always positive. If you think about the graph, it never goes into the negatives. Okay, so E to the X is positive, but I'm going to minus it. How's the top going to come out? Negative. Okay, then on the bottom, my biggest term is a squared. I'm going to take a negative infinity and square it. How's the bottom going to come out? Positive. And if I divide a negative and a positive, that's going to give me a negative infinity. All that means is that that end would end up pointing down. Okay. Let's do that with one more, but I don't care in general if you do this on everyone. I just want you to know how to do it. Let's do it on, where did we get another D? Go to number 9. Okay, number 9, take a look at letters B and C. This is, I think, one of the only ones where the equation's not the same. But look at letter B. Is it a Bobo, a Botan, or a Betsy? Okay, it's a Botan, which means that it is DNE, yeah? Okay, this is number 9. Okay, if I asked you to tell me which way that end is going, all that you would do is take your infinity and plug it in. If I do an infinity squared, how does it come out? Okay, what about if I just have an infinity? That's positive. Divide two positives, you get positive infinity. Okay, now let's do negative infinity on C. I already know it's a Botan. We already know it's a DNE. But the question is, which way is that end pointed? Is it pointed up or is it pointed down? All that you have to do is take your negative infinity, plug it into the biggest thing on top and on bottom, and then divide. What is going to happen to my negative infinity when I square it? It's going to turn positive. What's going to happen to my negative infinity if I just put it on the bottom? It's going to stay negative. And if I divide a positive and a negative, that end points to negative infinity. Okay, if that confused you, you can still get 100 on your test. It's not on, okay? All right, I'm gonna give you a couple more minutes and then we're gonna finish your cheat sheet and do a few examples from the other section.
How many questions on this one?
But it's not that one.
Oh,
Like it's not even that. So absolute values for every two weeks, not the opposite. We'll turn this on, but you do the absolute value of 5. Well, you don't have to do the 8.
I know.
Oh, okay, then it.
Thank you.
Okay, so over there, if you cross out for the top, we got. And then you're gonna take. You're on line. So remember. You're on line. You want it, Jack? Hold up.
Anyway, you talk about like that. It's like the actual girl.
Okay. And then for the
Right. You know what it is? I don't know.
Good job.
I'm very glad.
How we doing?
Pretty good.
So for x infinity, then you're gonna keep it on pi over 3x. So pi would count as 3x. Even though it's the power of 1, it's still a power. So which one would be bigger? Which means that the middle of that goes to 0. But then you have a
Anyway,
and you'll find
then
the
you
sign of.
Now she wanted to be changed.
Because you'd be here, you have all four fingers, remember it's with.
She wanted to be changed. Anyway, so she said to me, she's like, when the, and he's good morning. And that's like, that's all I was telling him, good morning.
How are you?
Yeah.
So, you would be here, right, but like, next time we see him, like, when I'm walking back there, I'll be like, what?
All right, if you would please get back out your cheat sheet and flip over to the back side, we're gonna finish filling it out. Okay, to make your notes go a little bit faster, okay, I already drew the picture for you. Okay, girls, are we ready? All right, so a removable discontinuity is also a hole. Okay, but remember, they're gonna call it a removable discontinuity. Hole's what it looks like, but remember that for that, your limit still exists. Okay, girls, we ready? Okay, for non-removable, there are two types. Okay, do we remember the name of this type? Okay, jump. And you should be able to tell from your picture that your one-sided limits exist, but they don't equal each other. Okay, and then do we remember for an asymptote what it was called? It's infinite, very good. Okay, and then just to clarify, it doesn't have to be that your asymptote is up. It could also be an asymptote down. You would still call that an infinite discontinuity. Okay. All right, then your horizontal asymptotes. If you are doing the left end, x should be going to negative infinity. And you should be able to write that as a limit statement. So you would say my limit as x goes to negative infinity equals, and then whatever that asymptote number is. Okay, for the right end, what's the only thing I would change? Your x should be going to positive infinity. And then it'll still equal wherever that horizontal asymptote is. Okay, for a vertical asymptote, okay, you're still gonna write a limit statement, but your x is gonna approach wherever your vertical asymptote is. And then your answer will equal either plus or minus infinity. Okay? So before we go on to the bottom two sections, we're gonna do the examples that have to do with this off your review. Then we'll come back and fill out the bottom. So will you go to the very first page of your test review? And look at number 2. Okay, number 2 asks you to list all of the discontinuities in the graph. Remember, a discontinuity is if you were to draw it, where you would be picking up your pencil. So we're gonna label the different types. We're gonna start off with removables. Okay, can you find where the first removable discontinuity is? -7. Is there one more? There is one more. Where is it? 8. Very good. Now, quick question. Should I also count 6? Because it's got a hole? No, that's not a removable. What type is 6? This is a jump. Okay, so I'm going to put that I have a jump at x equals 6. Okay, then there's one other type. It's an infinite. That would be anywhere that I have a vertical asymptote. Where does my vertical asymptote happen at? Okay, so my infinite discontinuity is at x equals -2. So looking at a graph, you should be able to tell what type it is from those descriptions. Okay, go ahead and turn the page. You have 2 graphs where you're asked to put the limit statements on your asymptote. So we're gonna do number 4. Okay, number 4, how many vertical asymptotes are there? Okay, 2, there's one here, and then there's one here. So let's write those 2 limit statements. Starting with -1, my limit is as x approaches -1. And then what are the ends of the graph doing as I get closer and closer to -1? They're going up to infinity. So I would write the limit as x gets closer and closer to -1 is going to positive infinity. And the positive indicates that that vertical asymptote is up. Okay, and then I'm gonna put here, that was a vertical asymptote. Okay, you have one more over here. Where is my asymptote at? What x value? X approach 6. But which way is that one asymptoting? Towards negative infinity, because both ends are down. Okay? So you should be able to write limit statements to match vertical asymptotes. You should also be able to do that for horizontal asymptotes. Do I have one of those here? Okay, on which end? The left end or the right end? Okay, the right end. On this side, I can see that my graph is flattening out. So put HA for horizontal asymptote. What will X be approaching if this is a horizontal asymptote? X is going to infinity. And then what number is it curving off to? -2. So do we see the difference in the structure of those 2 types? Okay, now on the left end, you'll notice that you don't have an asymptote, but you can still write a limit to describe what that end is doing. So I'm gonna put no HA so that you know there's not an asymptote on this side, but I can still describe the end behavior. What will my limits X be approaching? That tells me that I'm at the left end. And then how would I say it's going down forever without getting close to a specific number? Negative infinity. So what that means is the left end is just going down. It's not going towards anything specific, it's just going down forever. Okay, do we feel okay with that? All right, go back to your cheat sheet. We're gonna fill in your bottom box. Yes?
You don't need to put the class.
For these instructions, no. But on your test, I think it asks you to label the end behavior on both sides. So if it doesn't have one, you would do it there. All right, your last box is gonna be continuity. Okay, intermediate value theorem, we actually haven't covered yet, but we're gonna cover it soon, so I just put it on the sheet. Okay, so this is intentionally blank, we're not filling this out. Okay, continuity, step number 1. We just covered this last class, so if you haven't watched the notes, you might be a little confused. Okay, but what was the first step? Do you remember? Anyone? Make sure they equal each other. What's the they? The left and right limit. So for number 1, you're gonna do the limit as x approaches a from the left, and it should come out to equal the limit as x approaches a from the right. If those 2 limits aren't equal, your graph is not continuous. You can stop and not do the rest of the definition. But if they do come out the same, the next thing that I check is my y value. Okay, and I have to get a number. It has to be defined. On a graph, I'd be looking for a closed circle for the y value. Okay, then the third step is that my limit and my y value need to be the same as each other. So my limit as x approaches a needs to equal my f of a. So my limit and my y value have to be the same. If all 3 of those conditions are met, then you'll put therefore it is continuous. Okay, that being said, let's do an example. Okay, if you'll turn back to number 2, the one that we just did part A for, now we're going to go back and do part B. All right, part B asks you to find whether or not the graph is continuous, but it says to use the definition of continuity. That means you need to structure it just like what you have on your cheat sheet. So the first thing that we're gonna find are the left and right hand limits. Write those down on your paper. The limit as x approaches 8 from the left. And the limit as x approaches 8 from the right. Okay, remember that for a left only limit, you put a little minus sign. For a right only limit, you put a little plus sign. Okay, then look at your graph at 8. Okay, 8's gonna be here. And remember, to do a left and a right limit, you're only gonna look at that half of the graph. So if I wanna do a left side, I'm gonna pretend like the graph stops here, and I'm just gonna see where my graph leaves off at. Okay, if I cut the graph off here, what's my y value at 8 looking like it's gonna be? -2, put a -2 right here. For my right side limit, I'm gonna cover up and only look at the right side. So if I cover that up and I trace towards where my graph gets cut off, where does it leave off at? What y value? Did they come out to be the same? Then you go on to the next step. The next step asks me to find my y value. So I'm gonna look back at my sheet. Okay, left and rights came out the same. Now I need f of 8. F of 8 is my y value, which means I need what kind of dot? A closed dot. Do I have one? What number? -4. Okay, the third step is that the limit and the y value had to equal each other. What did my limit equal? But my y value equaled -4, then I would say it is not continuous. So let's write that third step. Okay, if you don't put the Roman numerals, that's fine. Okay, I put them there just to organize my work, but that's up to you. Okay, you would say that my limit as x approached 8 came out to be -2, but my y value came out to be -4. Therefore, not continuous. Okay. Now, when you take your test on Friday, okay, if it's multiple choice, I do not expect you to do this. You could if you want to, okay, but if it's your free response portion where I'm grading your work, okay, that's where I would expect to see this, but it'll say very clearly, use the definition of continuity if I want to see this, okay? All right, go ahead and turn the page, please. Okay, we're gonna do a couple off the last page, maybe 2 of them, and then we'll be done. Okay, take a look for me, please, at number 30. Okay, it says, determine whether or not the graph is continuous at its breakpoint. Use the definition of continuity to support your answer. What is the first thing that I do if I'm checking continuity? I do the left and right limits separately. So write that down. I want the limit as x approaches 9 from the left. And then I'm gonna do the limit as x approaches 9 from the right. Now, when I want x to approach from the left, I'm gonna use x's that are less than that number. And when I wanna approach it from the right, I'm gonna use x's that are greater than that. So I'm gonna write that on here. I'm gonna use x's less than 9 for the left side. And I'm gonna use x's greater than 9 for the right side. Now, which piece of the piecewise is just gonna give me a value, the left or the right? Okay, all the greater than 9s, what's the answer? 7. We don't have to do any work on that side. So the question is this left graph gonna come out to 7? Or is it gonna come out to something different? Let's check it. We're gonna find x minus 9 over root x minus 3. First thing I'm gonna do is plug in x approaching 9. But what's gonna happen when I do 9 minus 9 on top? What about root 9 minus 3 on bottom? 0. And when you get 0 over 0, what do we have to do? Do more. So this is gonna be a conjugate question. Okay, which I don't know if y'all did this, hopefully you did, but if not, I know my kids did it. So root x minus 3 has a conjugate, what is it? Root x plus 3. And if I multiply it on the bottom, because remember, I'm trying to fix my limit, I have to also put it on the top. So I'm gonna do a root x plus 3 on top as well. Okay, now, when you're multiplying, remember, you only times together the pieces that are conjugates. Something special happens when you times conjugates together. The top of this, though, I'm not gonna times that out. So I'm gonna keep my x minus 9 and my root x plus 3 just the way it is. Okay, but then on the bottom, I'm gonna actually times it out. What is root x times root x again? Okay, root x times x, root x is regular x. Okay, my next two terms are gonna be root x times 3. What's that? 3 root x. And then a minus 3 times root x is gonna be a minus 3 root x. Okay, last term is gonna be negative 3 times 3, which is negative 9. Now, look at your middle terms. Hopefully you can read them. I wrote them in yellow because what's gonna happen to those two? They're gonna cancel out. Every time you do conjugates, that should happen. That's the whole point. So now on bottom, I only have an x minus 9. Where else did I have an x minus 9? On the top. So I'm gonna rewrite this, but you don't have to if you don't. Okay, on the top and the bottom now, I have an x minus 9, then those cross out. And now that the bottom is fixed, essentially, I'm gonna retry my limit. What was x approaching? The number 9. And if I plug in a 9 here, I have root 9 plus 3. What is the square root of 9? 3 plus 3 is 6. So my left side limit came out to 6. My right side limit came out to 7. So would I go on to the second step for checking continuity?
No.
No. Therefore, not continuous. Okay, those left and right sides have to come out the same for it to be continuous. And so if they don't, you know, you're done. Okay, last question we're gonna do together. Turn the page, please. Okay, the instructions on this page, I don't know what happened to them, but it's just like the last questions we did on your notes last time. Okay, you're gonna find the constant that will make it continuous. Okay, you're gonna find the constant value to make it continuous. And so if you remember what we did for these, we're gonna take the left and the right sides, we're gonna set them equal to each other. Okay, so let's say we're doing number 33. Okay, I'm gonna set the left equal to the right. And then plug in the breakpoint. That's the strategy. Okay, BP stands for breakpoint if you want to write that out. So my left limit is k squared minus 6x. My right side is 2kx. And what is my breakpoint for me to plug in? Plug in x equals 2. Okay, make sure you're plugging it in for x. We're solving for k. So don't plug it in for the wrong letter. So I'm going to put a 2 here, and I'm going to put a 2 here. So I have k squared minus, what's 6 times 2? So k squared minus 12. Now I have a 2k times 2. What's that? 2k times 2 would be 4k. Okay, and then from here, the reason there's a star on this is the question on your test is very similar. If there's a k squared, what do? How do I solve it? Do you remember? Factoring. And can I factor with the 4k on the other side? You gotta bring everything together to factor. So I'm gonna minus my 4k across. So that I have k squared minus 4k minus 12 equal to 0. Okay, I'm gonna A, B, C. If you factor in your head, that's fine. Okay, but A times C would be 1 times -12 is -12. The only way I can times to get to 12 would be 1 and 12, 2 and 6, or 3 and 4. Am I adding or subtracting if the top is negative? Subtracting, and what do I want it to be? A -4. So which of those numbers are gonna minus to give me -4? 6 and 2, which side should I put the negative on if I want the 4 to come out negative? On the 6. So then my factors are K plus 2 and K minus 6. But remember, your solutions end up being the opposite of those. So if K plus 2 is the parentheses, what is the answer? -2. And then if K minus 6 is the parentheses, the answer is really +6. Okay, for your test, if it's a K squared, you should be giving me 2 answers back. If it was a K cubed, you'd give me 3 answers back. So the power on K tells you how many final answers you should have. Okay, I'm gonna post the answer key onto Schoology right after school today. Actually, I'll probably do it right at the end of this period. Okay, check your work. But I know Mr. Castrejon, your reviews were extra credit. Okay, they're a grade for me. So don't not do it. Okay, it's going in as a quiz grade, and I'm giving you the key so that you can check and see if you did it right. I'm completion grading it. Okay, so make sure, don't show up on Friday with it not done, or you're not gonna get a good grade for an assignment that you have a lot of time to finish, okay? Let me know if you need help. You have about 15 minutes left. Yeah. You can go. Just go. It just means it could be any number. Same thing up here. Arbitrary constant though means it could be any number, versus here we're finding the value of the constant. So here, you're gonna let your A be a 2. You're gonna see if the sides come out the same. And then when you go down here, you wanna make it be continuous. So then you're gonna set an equal. Yeah, let me read this.
Yeah, well. No, all right, it's fine, we'll read it.
Yes.
Yes,
So
you're
they
right.
have to take off the bottom.
Well, like, all you're like the exact same. He's like, well, yes, the same, and he goes, oh, they are all the same. And like, the whole thing, like. What is it, what is it? Oh my god. You take it out and work.
Yes.